If I were to say the words additive layer manufacturing, you might well be a bit confused. But if I were to say 3D printing, suddenly everything becomes clear. After decades of research into various methods, 3D printing has come into its own in the past 5 to 10 years, and it is the current buzzword in engineering and manufacture. It opens up a whole plethora of new opportunities, designs inspired by nature that are no longer limited by traditional manufacturing methods. The thing is, how do we take advantage of 3D printing? Well, the answer to that is finite element analysis and topological optimization. Don't panic. Those are big words, but it's really easy to explain. And I'm going to do it using this apple that I found in the back of my fridge. Imagine that this apple has been put into our analysis software. The software then splits it up into a number of different elements, like so. Then the computer will simulate what were to happen if a force were to be applied to each of these elements, bringing it all together to predict the behavior of the whole apple. That's all well and good, but we can apply topological optimization to then work out what material is being useless when the load is actually applied. So we can come up with a lighter, more efficient design for our apple, as we can see here. Now, that's a very simple explanation, but using a process that I've developed, we can actually predict how our new design will behave in real life. The thing is, that's all inside a computer. How does the simulation compare to reality? Well, to answer that, hold your breath. An engineer is going to do an experiment. This is something I made earlier. This is a simple cantilever beam that has been optimized, as you can see here with these holes through the structure. What happens is a load is applied and it is going to bend. So first and foremost, what we're going to do is we're going to mark here on this step structure that I've made here where the beam is going to start from. So it's starting there where that pencil mark is, as you can see here. And then what we have to do is stick it on the end of the table and apply a load. The load in this case is a bag of onions and carrots with the equivalent of about 21 newtons. So as we can see here, it's starting there, it's not bent, it's perfectly horizontal. When I let go of the bag, it bends down. And now all we have to do is we have to mark here where it's gone to. If I move it up here, I can show you. You can see it's finished in a different place. That is where it finished. All we have to do then is compare the distance between those two. That's the distance that it actually deflected by. Compare that with what the computer said was going to happen, and all of a sudden we are able to work out how accurate the computer simulation is. And using all of that, we can actually take full advantage of 3D printing with new and complex geometries and fantastic designs that push engineering to the limit.